Okay, so for this activity, we're going to go ahead and do a little bit of graphing. I'm going to plot the aluminum data right here. I'm going to use it for something, but that's what the big thing is, going ahead and graphing it. All right, so in order to do so, I have to go ahead and set up my graph. And what I've noticed is I got about 30 lines going across on the x-axis and 40 lines going through the y-axis. And I can look and see what my top numbers are. My data for my aluminum goes from 3.7 to 1.5 on the volume axis. We have that still here, right? 3.7, sorry, to 15. And then the mass goes from about 10 to about 40. And I'm only really worried about the top number. And so what I've done is I've gone ahead and counted out the number of lines on the X and the Y. And so I think I'm going to go ahead and I think, since there's 30 lines here, I can make each one of these things, each 2 lines, 1. So I could go ahead and say, that's 1. And then go the exact same distance and go 2. And the exact same distance go 3. I have to be consistent with how I go up. Each time I change this thing here, I have to go up by 1. And I'm going to do the same thing for the side, but I think I have 40 lines and my top number is 40. I'm pretty sure I can just go up by 1 each. 1, 2, 3, and 4. I can do that, and that's what I'm going to do. So when I really look at it and I take a look and I see one that's going to work for me, it's going to look like this. Okay, and so this is my graph. That's what it goes from. On the side will be my mass, which I'll put on there in a little bit. On the bottom will be my volume, which I can do already because I have space. I have it in milliliters. And I'm going to have the mass grams. I'm going to label my axes the right way, just so I can see them. I'll flip out a little bit, sorry. Okay, so I have it so I can see a little bit better. So then I have it there. And now I'm going to go ahead and plot the numbers. Well, the numbers I have are here. And so I'm going to fold this sheet of paper in half. That'll be up on the bottom. All right. And so what I'm going to do is I'm going to plot these 2 numbers. So my first one's going to be, the volume will be 3.7, which is somewhere over here, all the way to about 10. So 3.7, sorry, 0.7 all the way to about 10. So it's right about there somewhere. Guessing, right? Each line is a 0.5, right? So somewhere in the ballpark over there. And my next number is going to be 6 and 16.2. So I go to 6, my volume, and go up to 16.2, 6, all the way to 16.2, and that's about there. I probably should do this with a pencil and then redo when I'm done. The next one should be 8.5, which is here, all the way up to about 8.5, all the way up to about 23 I have, right? So 22, that'd be 22, that's 23. 8.5, 23. My next one's going to be 10.74, so somewhere over here, up all the way to 29. So I'm going to go all the way to 29. That's 28. That's 29. Okay, getting a little bit low on my scale here. And then my last one's going to be 15, which is all the way at the end over here, all the way to 40.5, right? So let's just back in my paper. Way. So I'm going to start all the way over here at 15 and go all the way up to 40.5. So 15 is like 2 over. 2, and now I want 40.5. Each one of these is going up by like 1, so I feel like I'm right about there. And then I'm going to go ahead and draw what I call my best fit line. All the lines kind of go through, and they shouldn't be about perfect, but they're not bad. They're pretty good. So I'm going to do it there. Include as many of them as I possibly can in my line. Sorry if I went a little bit off on that one. Okay, and there's my graph. And I'm going to go ahead and make sure I label this the right way. Mass versus volume. So then, once I have the line drawn, I want to figure out the slope of that line. Right? So just to make sure we remember how to do slope, what I'm going to do is find some spots. Well, I like to go ahead and find them where they cross the axes. I like that line right there. Can you see it's kind of crossing both axes? And I'm going to find another one, hopefully far apart. I like them as far apart as possible. There's another group, right? And what I'm going to do is I'm going to label the actual axes themselves. So this one is in the x direction, it's 1. In the y direction, it's 3. Okay, and then this one over here, I go up. You can see where I put it in. I'm going to go ahead and go up the line. So that one's going to be about, on the x-axis, 13.5. And then on the y-axis, it's going to be, 36. 13.5 and 36. Okay, so then I'm going to take the two of them together, and I'm going to do my slope. The slope is always rise over run, which equals, in this case, the second number is the y-axis. So that's the rise minus the second number, which is 3. Okay? And then the x-axis should be 13.5 minus 1. So then we end up with 33 divided by 12.1, which is equal to, clear it so we have it, go to the calculator, 33 divided by 12.5, which equals 2.64. And so this will be in grams, and this will be in milliliters, grams per milliliter. Okay? And that should give us the density. Let's see if we can find it relatively quick. So this should be the density of aluminum. Because density is going to be mass, right? Mass per volume, which in this case is a slope. The accepted value for the density of aluminum is 2.69. We got 2.64, so we did a pretty good job. The numbers work pretty well. Okay, so this is a plot of mass versus volume, and I'm going to give you some information. You're going to go ahead and do it on your own. You will go ahead and have one. Now, make sure you understand some things about density. That's much bigger than water's, which is 1 gram per milliliter. Okay?